Now here in session 106, we're going to take a look at inequalities. Take a look here. Our first statement says A equals B. That means that A is equal to B. This first example is actually an equality. And a lot of what we've been dealing with so far have been equalities. And as you can see here, an equality contains an equal sign. But our next four statements here are all inequalities. They're describing things that are not equal to each other. In this first one, it's A is greater than B. This is our greater than symbol. The second inequality here is A is less than B. In our third one here, we have a greater than symbol and then we have a line under it. That means greater than or equal to. So to pronounce this statement would be A is greater than or equal to B. And our last one here is a less than sign with a line under it, which means less than or equal to. So reading this statement, A is less than or equal to B. So once again, this first statement is an equality. The other four are inequalities, and they're describing characteristics about how they are not equal to each other. A is not equal to B because it's greater than B. A is not equal to B in this example because it's less than B. Now in this one, we have an option, or we have a possibility. We not only have a greater than, but we also have the possibility of an equals. A is greater than or equal to B. If A was absolutely equal to B, it would be our first statement. But in this one, since A can be either greater than or equal to B, it's still treated as an inequality. And same for our last statement, less than or equal to. For many of you, this is review. But one of the final things I wanted to look at here in this session was how to graph inequalities on a number line. First of all, we're going to use two primary types of dots. We're going to use a solid dot and we're going to use an open dot. The solid dot, when it's a point that's placed on a number line, means to include that point. A circled dot, on the other hand, or an open dot, one that's not filled in, means to start at that point but don't include it. Start with everything either just to the right of that point or everything just to the left of that point, but do not include that point itself. Well, what do I mean? Well, let me go ahead and give you an example here. Our first point that we want to plot here is x is equal to 1. Well, here on our number line, we would just simply come up here and put a dot there. That dot represents x is equal to 1. I'm going to go ahead and undo that there. Let's take a look now at our second example. X is greater than 3. Well, we need to choose 3 as our starting point, but if I were to draw a dot like this, that would mean include 3 as its point. And we're wanting things that are greater than 3. So instead of a solid dot, what we need to do is to put an open dot. That means choose this point here, which is at 3, as our starting point. And since it says x is greater than 3, we're going to draw a solid line to the right like this, and then just put an arrow on it like that. This graph here says choose 3 as your starting point and then include everything to the right of it. That corresponds to x is greater than 3. Let's undo that. Let's come to our next statement. X is less than or equal to 2. So our starting point here is 2, but x is not just less than, it can also be equal to 2. So in this case, since it can be equal to 2, we're going to use a closed dot instead of an open one. And then x is going to be less than that as well, less than or equal to. So if I were to draw the graph for x is less than or equal to 2, I'm going to start with a solid dot at 2, that's my starting point, and then move left, because on our number line, left moves in the negative direction, and we just put an arrow at the end. That arrow indicates that this solid line goes on forever in that direction. So here we have the graph of x is less than or equal to 2. Go ahead and remove that. Let's take a look at our final one. What if x is greater than or equal to -4, but less than 3? How can we graph this? Well, let's come here and start at our left and work to the right. We know that x is greater than or equal to minus 4. So I'm going to start off with a dot here. That means it includes minus 4. And I need to move to the right. But how far do I move to the right? Well, if I come down here to my number, x is going to be able to come all the way up to the number 3. But does it include the number 3? No, it doesn't. X has to be less than 3. Since it does not include the number 3, we use an open dot, an open circle. Since x can be not only greater than minus 4, but it can also equal minus 4, we use a closed dot there. And then we simply connect these two together with a solid line. So this graph here tells us that x is less than 3, but greater than or equal to minus 4. This then is the graph for our final mathematical expression, mathematical inequality here. Okay then, just as a quick review, equalities are mathematical phrases that are equivalent to each other. Equalities use an equal sign to indicate equality. Inequalities are mathematical phrases that are not equivalent to each other. There are four primary kinds of inequality symbols: the greater than symbol, greater than or equal to, less than or equal to. And once again, even in our greater than or equal to or less than or equal to, just because the possibility exists that that particular number can equal something else, it's not absolutely mandated by that. Therefore, it is still treated as an inequality. Okay then, that finishes up session 106.